So I had my students working on writing numbers in different bases, and it was a bit of a struggle. We kind of got through it, and then I asked them to do more of it, and we kind of struggled. And I think they see that there is a connection, but maybe the connection isn't as clear as I would hope. So I just wanted to show an example of taking a number and writing it in some different bases, and then showing how that connects to the concept of polynomials. So I'm just going to put a few random digits down. Let's go 4, 1, 3, 2. So 4, 1, 3, 2. If we write this in base 10, like our normal way of writing numbers, that means 4 times 1,000 plus 1 times 100 plus 3 times 10 plus 2 times 1. And I could write that out using powers of 10. 1,000 is 10 to the third, 100 is 10 to the second, 10 is 10 to the first. I know that feels a little redundant. And 1 is 10 to the 0 power. And I hope you notice that each power of 10 is the same as the number of zeros on it. And that's just the idea behind our decimal system, that when you move one place value over in decimal, you are getting 10 times bigger or 10 times smaller, and that's what the powers of 10 are showing. Now if I look at the number 4132, but I write it in a different base, something like base 5, then that means 4 times 5 to the third plus 1 times 5 squared plus 3 times 5 plus 2 times 1. And if I type that into the calculator, I get something. Let's see. I actually don't know off the top of my head. That'd be weird if I knew that off the top of my head. So see, I just typed it in to the calculator like that, and it gives me 542. So apparently, this number is 542 written in a base of 10. By the way, you might notice there's actually a little shortcut here. That number's 4 times smaller. Or not 4 times smaller. Never mind. There is a connection between the base 5s and the base 10s, but it's not quite as simple as 4 times smaller. It's just each of the powers got divided because the base 5 is half as big. So each of my place values got divided by 2 to that place value. So anyway, never mind. There's a little bit more of a complicated pattern. Let's look at one more example here, or let's do 2 more examples. Let's do it in base 2, and then in base 1. So in base 2, I'd put 2 to the third, 2 to the second, 2 to the first, and 2 to the 0, which is just 1. If you type all that in, I'm just going to change all my 5s to a base of 2 on the calculator. Looks just like that. I get that number, 44. I promise there's a point to this. If I write this out in base 1, 4 times 1 to the 3, 1 times 1 to the 2, 3 times 1 to the 1, 2 times 1 to the 0. And that just comes out to be 4 plus 1 plus 3 plus 2. And that ends up being, I guess, 10 in a base of 10. Okay. Now, what I told you guys was that when I think of the base as a variable, then this number becomes a polynomial. 4x to the third, 1x squared, 3x, and 2 times 1, because all of the powers of 0 equal 1. So when I write it out like that, what I want you to see is, let's draw the graph. Y equals 4x to the third plus 1x squared plus 3x plus 2. And what I hope you guys can see here, let's find some points. So let's find a point where x is equal to 10. let's see. I'm going to adjust my y values to go up to 5,000. There we go. And my x's are only going to go up to 10, 11. All right, this will make sense in just a second. All right, so if I look over here where x is equal to 10, I hope you can see that when I make x equal 10, look what number I get, 4132. So the number's value in base 10 is the same as the y value of the polynomial. If I go over here, let's move this out of the way, and I go down here to where x is equal to 5, I can see that the y value is 542, and that's the value of the number when it's written in base 5. When I write the number in base 5, it's worth 542, and that's the y value at x equals 5. If I go down here to where x is equal to 2, let's see if I can get it to show up there. Oops, almost had it. When I get it to x equals 2, I can see that y equals 44. And when I go all the way over here to x equals 1, I can see that y is equal to 10. Okay? And so the nice thing here is that if you understand how different numbers are written in different bases, then you also can understand why the graph has those y values when you plug in different x values. So the y values of the graph are the same as the value of the numbers that are written in different bases. All right, so thanks for watching. Let me know if you have any questions. Happy to help out.